Welcome, everyone. Thank you for joining the U.S. Department of Energy Solar District Cup Collegiate Design Competition's 2021 Pitch Championship. My name is Joe Simon, and I'm one of the competition organizers at the National Renewable Energy Laboratory. We are very excited to have all of you here with us to celebrate as these teams conclude their work over 2 semesters, and you get to help select the 2021 Project Pitch winner. As many of you know, the Solar District Cup is a competition that challenges student teams to design and model solar plus storage systems for a campus or urban district. This program engages and enables students across multiple disciplines, including engineering, finance, urban planning, sustainability, and more. Together, these students develop forward-thinking designs for an optimized campus or urban district distributed energy systems. This takes creative thinking to reimagine how electric energy is generated, managed, and used in these urban environments. In our second year of the program, we were pleased to see such great engagement from all of our competing students. With over 500 student participants, this past fall, the class of 2021 started with 59 participating teams from 57 different collegiate institutions, and ended up with 29 competing teams from 28 different institutions. Yesterday, all of our competitors presented some truly impressive project summaries, giving the judges and their peers a glimpse at what they've achieved over the past academic year. On behalf of the Solar District Cup organizers, I congratulate all the teams that participated in Solar District Cup 2021. Well done. This morning, we announced the first, second, and third place teams in each of our divisions. Now, our 3 first place teams, University of Puerto Rico, University of Colorado, and Embry Riddle Aeronautical University, will present 8-minute pitches to all of you as they compete in our pitch championship. Before we begin, however, I'd like to take a moment to recognize and thank our judges. Siddharth Tamburni, Dr. Chifeng Li, Kristen Forns, Alex Parlato, Dana Claire Redden, Dr. Olga Larova, Ben Schneider, Dr. Linda Pickett, Bakary Kulabali, Akshay Jain, Rachel McLaughlin, and Chris Hare. Thank you all. You spent a lot of hours, a lot of time, and shared your expertise to carefully and thoughtfully select the division winners. We really thank you. It helps the students understand how they can be prepared for industry and how the real-world problems they solve with their assigned district use cases are relevant and interesting and exciting for industry professionals such as yourselves. I'd also like to thank our partners, Aurora Solar, Heat Spring, and Solar Power Events, as well as our district use case partners, the City of Denver, the Auraria Higher Education Center, the University of Central Florida, and the University of Nebraska-Lincoln for providing numerous resources and learning opportunities to these participants. These district use case partners provided data. They provided key information to each of these student teams. But speaking of partners, I'd like to introduce Sunny Wang, Director of Communications and Government Affairs at Aurora Solar, who provided all participating teams with access to their solar system design software, offered customized training, and joined office hour sessions throughout the competition. Sunny, thanks for joining us today.
Thank you, Joe. I'd like to start off by sending a massive kudo to you and the entire team who designed, organized, and executed another successful Solar District Cup Collegiate design competition. I think a lot of time and thought went into this hands-on learning experience for the students across different campuses, and it really shows. It's been a pleasure being a part of this experience and a sponsor. And to each division's first, second, third place winners, congratulations. Not only do you have bragging rights, you're going to be receiving one of the best design trophies I have ever seen. I'm not even lying. I sincerely feel that every student who participated in the Solar District Cup are winners. I know it sounds cheesy, but it really is true. You've gained a depth of knowledge that you couldn't have received inside a classroom reading a textbook. You've made connections with different industry professionals, and you've made a commitment to this competition and followed through in the year 2020, no less. It's one of the weirdest and toughest years for so many reasons. And for those of you graduating this year, I can only imagine the added stress of job searching with COVID-19 pandemic still dominating the news. But if you have doubts, I do want you to know from my side of the camp that companies are hiring again and searching for talent. And for every student who participated in this competition, this is a project that I highly recommend all of you add to your resume. Andrew Gong, who is a huge supporter on Aurora's side, he's one of our research engineers. He couldn't be here with us today, but he would agree. I mean, Andrew participated in the Solar Decathlon, which is another DOE collegiate competition. And he said that the learning experiences that his team gained has helped a lot of them get an interview. So please add it to your resume. It is a very unique experience that demonstrates your ability to work across multiple disciplines, coordinate a project with hard deadlines, think holistically, as well as your ability and willingness to stretch your bandwidth on top of your school courses. And as you're getting ready to launch your career, please don't be shy or afraid to reach out to people for help and insights. If they're not responsive, try again. And then again, from my time working at Stanford University, where so many big names have come through and still do, more often than not, they're all very willing to help students and answer questions. It's just that sometimes the email gets lost in their inbox. And when you're considering your options, please keep an open mind. I don't think either Andrew or I thought that we would be working for a solar software company, yet here we are, both about 4 years in. And also, you can move across job sectors. So I moved from city government to academia before Aurora Solar. So don't feel like you just have to stay in one. So my email is on the slide. Please feel free to reach out anytime. We will keep your accounts active through the end of May. Congratulations again to all of you and to each division's winners. And good luck to the first place teams pitching today. Thank you, Joe.
Thank you so much, Sunny. That was really great. And I remember working with Andrew through other programs, and he's been so engaged with the students. And I hope that you too become students that work to industry and continue to keep that community and relationship alive. Next, I'd like to introduce Kelly Speaks-Bachman, Acting Assistant Secretary for Energy Efficiency and Renewable Energy. Kelly?
Thanks, Joe. I am so excited to be with you all here today. And my gosh, Sunny, you had such great pragmatic advice to give. I thought that was just an awesome opening remarks. Look, I'm just excited to see all the creativity on display from the teams today. Their work is part of this next great wave of innovation that's going to change the world. The acceleration of a new clean energy economy and these technologies that are going to build a more sustainable future. I have the honor, the just distinct honor, it's unbelievable to me sometimes, of leading the Office of Energy Efficiency and Renewable Energy at Department of Energy. We have the most urgent mission that I can imagine, accelerating our country's transition to a net zero economy by 2050. I'm confident now that we're going to get there because of the kind of talent that we see today among the Solar District Cup teams. This competition represents just one creative way our team supports the development of an expanded clean energy workforce. If we can harness all the energy, all the talents and innovative spirit of these students who will soon be a part of our American workforce, we can turn this threat of climate emergency into an unprecedented opportunity. As President Biden likes to say, his climate plan is a jobs plan, a national effort aimed at creating jobs for Americans to build that modern, sustainable infrastructure that we so sorely need, and to deliver an equitable, clean energy future that's going to benefit all Americans. So thank you for having me here today. I'm so excited for the day, and back over to you, Joe.
Thank you so much. Now it's time to get started with our Project Pitch Championship. As I mentioned earlier, each of our first place teams will present an 8-minute project pitch, telling you how they address the Solar District Cup's fundamental challenge, designing and modeling solar plus storage systems for their assigned real-world district use case. After all three presentations conclude, you, as our audience members, get to assume the role of judges and vote on which team you think should win the Project Pitch Award. Let's kick things off with our first presenting team from the University of Puerto Rico. They were chosen as the winner of the Denver and Auraria Division for their excellence in engineering design and their compelling demonstration of value to the district. As I see their cameras come on, we're going to switch to their presentation and welcome them to the stage. It's really exciting to see all of the different innovation, the passion, and the work that these students put in over multiple semesters. They asked questions as we had office hours. They worked with the tools and the resources that were provided, and they found mentors in their own community. In many of our schools that competed, they didn't have resources built into their university, and they had to be creative about learning about the opportunities that are solar and energy storage. It looks like the slides are up, and I see several students ready to present. And so with that, I turn it over. Good luck.
Are we ready? Okay. Greetings to everyone. My name is Michael Vasquez-Nieves, and I will be the first presenter of the University of Puerto Rico, Mayagüez campus. First, we have our faculty advisor, PhD Eduardo Ortiz. In the next row, we have our graduate students, and in the last two rows, we have our undergraduates. As a team, our goal was to design and implement a photovoltaic system, to design an energy storage system to energize critical loads, and to propose an economically viable solution. Now, I will be presenting the PV system designs. In the first table, we can observe the row spacing, the maximum panels in series, the minimum solar access, and the minimum TSRF for the majority of the PV system designs. In the second table, we have the average tilt, the average azimuth, the average annual TOF, and the average annual TSRF for Aurora campus and City of Denver, respectively. Here, we can see all of the electrical components and how are they connected. Now I'll be presenting the PV system design for the City of Denver. In the image, we can see the rooftop of the convention center. The pink area represents the current renovation, while the green ones represent the 7 areas where the photovoltaic system were placed. In the image above, the green circle area is a historical building, so we propose a PV system design, but additional permits are required. This is the City of Denver layout with the respective PV system design. At the bottom right, we can identify the building with the greatest solar potential, which is the Colorado Convention Center. Here we can observe the system type, the annual production, the number of panels and inverter for the convention center. Here we have the system type, annual production, number of panels and inverter for all of the 3 buildings that compose the art complex. And finally, this table shows the total system type, annual production, and number of panels and inverter for both convention center and Denver art complex.
Now we have the area higher education center part. For the area campus, we did analysis studies to select the best building for us to design the PV systems, where the top 4 buildings with best viability were Cherry Creek, Boulder Creek, PE Event Center, and the Science Building. For the campus, the main restriction was the minimum daytime load, which was calculated by the OpenDSS team, for which we were allowed a maximum production of 25% more of that value, and our designs comply with the restriction as seen in the table. Here in the slide is a summary of all the designs done in the campus. Now we have the general layout for the campus with all the designs done in it, where we have the 4 selected buildings and a section of the Holy parking lot in the campus. Now we have the Science Building design, for which this building we were given a challenge of adding an energy storage system that could support a critical load of 30% of its consumption in case of an emergency. Now we have the energy storage solution we did for the Science Building. At the right bottom of the image, we have the suggested location for the energy storage system for the Science Building, where the structure circulated on blue is the battery and the other structure is the power station. In this slide, we have the Science Building PV system and energy storage solution diagram. For this part, we did a resilience analysis that included the PV system design and a battery system able to survive a 24-hour outage, which was the worst case scenario for an outage. Now we have a few suggestions to implement to the campus for them to meet their sustainability goals. First, we have ABB's electric vehicle chargers, which we recommend are installed and connected to the array in the Holy parking lot. And last, we recommend the solar sun charging stations, which we have several charging methods for electronic devices. Both suggestions help the campus make a statement and educate students at the same time. Now we'll leave you with Angel and the system and impact analysis.
Hello, for the system impact analysis using OpenDSS. These are the transformers within the Aurora campus. The blue ones are where the design PV systems are connected to. Each building that has a PV system will have it connected to its transformer. Each PV system was connected using the voltage on the lower side of the distribution transformer. The Kim building holds the parking's PV system connection. This graph represents the energy production throughout the year for the PV system connected to the Zion building. Notice how the highest amount of energy production happens on the months of the summer. This gives the team a point of interest for this time. Next slide. Notice how even after 58 hours outage, the battery still has more than 75% chance to cover all the critical loads in the science building. REOP also provided the battery's load shape curve that was used in the OpenDSS code. The proposed PV system and battery storage did not produce any overloads nor voltage exceptions on the grid. The system works perfectly. Now we'll leave you with Maria for the financial analysis.
Thank you. I'm Maria, and I'll continue with the financial analysis. To determine the PPA price for the Aurora Higher Education Center, the team focused on making sure there were annual customer savings, but also an attractive IRR. So the PPA price that could achieve this was 0.04 cents per kilowatt hour, and annual customer savings began year 4, and the IRR reached 6.03%. For the city of Denver, it was considered that it is a community solar project. Therefore, the calculated PPA price resulted in 0.062 cents per kilowatt hour. The project's IRR reached 14.55%, and annual customer savings start year 1. I'll leave you now with Melody, who will discuss the development plan.
Necessary permits for the construction of the system were identified, including the approvals for landmark preservations that will be required for the Ellie Colkins Opera House. The calculations for the estimated work analysis, we calculate the time needed to complete each system. It was assumed 8 man-hours per kilowatt, and assuming each person works 40 hours per week. This represents a total of 5,400 kilowatt size system and a maximum of 14 weeks for estimated installation time. Construction timeline is divided into 3 stages. Initiation stage starts on June 1st and finish on May, construction on May 1st and end on mid-September, and final connection from September 11 to September 25. This timeline may be subject to modifications. Here we present some of the most important recommendations as a strategy to engage community members, like websites, social networks, project demonstration tours, solar zones and charging stations, conference and sustainable projects and programs at the university, interactive maps and solar innovations, and educational purpose, recognition programs and local competition as Solar District Hub, and collaborations with nonprofit companies. Our system contributes to achieve the goals of Denver use case in different ways. Some of this, the solar capacity and production of renewable energy annually. In the case of campus, almost 3,600,000 pounds of CO2 emissions will be avoided per year, and at the city, 6,800,000 pounds approximately. Coupled with PV system at our purpose, a monitoring system connected to accessible screens for education and customer savings starting by year 4 to year 1, campus and city respectively. We think that all teams should win this competition for the reasons mentioned in the previous slide, and because we achieved to design a system that complies with all the requirements of this competition, we were able to suggest an energy storage system that will improve dramatically the efficiency of science build while maintaining an attractive PPA prices for the campus, and we propose a very good plan to engage the community and increase awareness for the benefits of renewable energy. Thank you for your attention.
Thank you so much. That was a lot of information. I really appreciate you taking the time to share it with us today. So now we're going to let that team turn off their camera as the next team turns theirs on and we bring up their next presentation. Our next presenting team is the University of Colorado, Boulder. They were chosen as the winner of the University of Central Florida Division for their excellent financial analysis, great work on development aspects, great work on their construction schedule, very appealing proposal, and a solid presentation. I see the students on, and I'm going to wait one moment until we see their slides. But again, I'm just so impressed by all the students who learned new technologies, thought about the impacts on the distribution system impact. They thought about financial modeling, went outside their comfort zone of what might already be taught in their schools to think about how this can be implemented at scale in their communities and for these district use cases. With the presentation shared and the students on screen, I turn it over to University of Colorado Boulder. Begin whenever you're comfortable. Good luck.
Hello, we are the University of Colorado Boulder team, and as just mentioned, we've been working on the use case for the University of Central Florida, and this is our pitch proposal.
We were tasked by the Department of Energy and the National Renewable Energy Lab to design comprehensive distributed energy generation with solar, photovoltaic, and battery storage systems. University of Central Florida wants as much economic solar production on their campus as possible with as little excess net exports. Financial sustainability is important, but the focus of this project is going to be on energy independence. University of Central Florida wanted energy incorporated in a way that flows with their campus and optimizes space without interfering with future land use plans. It is also very important to highlight that UCF is located in an environmentally sensitive area. We are provided with 3 design areas for this competition. This includes the central campus rooftops, a parking garage, a plot of land, and a retention pond. We designed and optimized every possible system in each of those zones.
So we have 4 proposed systems, the first being a ground mount system producing 18.2 gigawatt hours annually. This is a great way for UCF to attain their goal of carbon neutrality by 2050, due to this system making up about 85% of our combined system annual production. The spacing between the arrays is set for optimal sunlight for each panel, as well as sunlight for agrivoltaics, which would be a great option for this ground mount system. Agrivoltaics are extremely beneficial because they not only provide shading for panels not only provide shading for the agrivoltaics, but the crops also provide a cooler microclimate that increases the efficiency of the panel.
There are a few major development considerations that constrained our design and development plans for the ground mount system. Just to the east of this property is a residential zone, and due to local zoning ordinances, we had to stay at least 200 feet back from this area. In addition to this, we had to be sure that the design complied with local environmental regulations and permitting requirements, and this entailed planning to conduct several environmental studies in the area to ensure that the system won't cause any harm to the nearby wetland conservation areas, any native species or habitats, or the Econ-Lockhatchee River Protection Zone.
So we decided to install a battery system with our ground mount. We used an NREL software called Reopt-Lite to do this. Reopt allowed us to optimize the size of our battery, which, as you can see in the figure at the bottom of the page, was less than 1% the annual production of the ground mount. This size was decided on because it allowed us to balance the financial advantages of peak shaving and load shifting with the battery against the capital costs of implementing a battery storage system. The siting of this battery was based on soil data in the region as well as distribution system modeling.
So our next system is the photovoltaic system, which is our second largest with an annual energy production of 1.3 gigawatt hours. This system provides UCF with a way to be on the leading edge of solar with novel technologies. This system has a higher environmental efficiency due to the colder water, keeping the system from overheating. And it's great because it both maximizes the space being used while minimizing the complexity.
Carports are the next proposed photovoltaic installation we'll be discussing today. This is our 3rd largest and most efficient system. The canopy structure will fit snugly on top of the parking garage so that we can utilize the land for energy generation without sacrificing any of UCF's valuable real estate. UCF wants a visual demonstration of solar capability, so we designed side-mounted photovoltaic systems oriented towards the center of campus. As you can see on the southeast and southwest facing walls just above the tree line, there are 2 awning-style systems. As these are mounted directly on the wall, this will be much easier for campus population to see the innovation and how UCF is dedicated to their mission of sustainability.
So for our last system, we chose to create a rooftop system on the Student Union building with an annual energy production of 437.6 megawatt hours. This system is our smallest, but it does have a very unique visibility with the building being at the center of campus and having multiple layers of roofs.
So for all of our proposed and developed rooftop systems, we used OpenDSS to analyze the interconnection impacts of our proposed distributed generation. As you can see in the first table here, we found that in both cases, we did not increase the number of voltage violations, and we were actually able to offer UCF's distribution system a net decrease in thermal overloads due to some of our recommended upgrades.
So we have decided to go ahead and give each of our proposed PV systems their own dedicated transformer to tie it into the grid. But in the process of analyzing the thermal overloads, we also identified 3 different transformers on the UCF grid, as well as one of the existing transformers that was previously dedicated to the photovoltaic system. And all 4 of these transformers were routinely experiencing thermal overloads well above their emergency limits. So the second table here shows these 4 transformers' existing ratings and the ratings of our recommended replacements. The final row is just a recommendation to use a stronger type of wire for the ground mount lines that will need to be installed for the ground mount system, since they just have to handle more power than really anywhere else on the grid. But as Devin said, with these upgrades in place, we should be able to decrease thermal overloading from where it is now, so we don't anticipate any major problems with interconnecting the proposed PV systems.
So for the optimization of our proposal, we looked at 3 key metrics for UCF. We looked at the energy independence our systems could provide them, which we measured with the annual production of our systems. We looked at the customer savings we could provide to UCF, and we looked at the visibility of the PV systems on their campus. As you can see in the figure on the left, adding systems to the ground mount tended to decrease the customer savings UCF could expect, but it increased the annual production we could provide to them. The option in the middle there shows us that larger systems such as the carport and photovoltaics allowed us to maximize the customer savings while still supplying a reasonable amount of annual production to UCF. In the figure on the right, we looked at the implementation of our battery system from a financial standpoint. We see that there is a decrease in annual production, but with an increase of almost $500,000 in customer savings, we decided to propose the implementation of this battery storage system to UCF.
So for our proposed system that we found after many design and financial iterations, we sized it to be as large as possible to accommodate UCF's desire for carbon neutrality and sustainable energy independence. Overall, it's about a 15 megawatt system with a 361 kilowatt battery and a lease price of around $148,000. PPAs are disallowed in Florida, so we had to use lease prices. For UCF and the savings that they can expect to see by pursuing our recommended 20-year lease contract, it can be anywhere from $300,000 to up to $1.5 million, and this is depending on the highly variable demand savings. So for our investor economics, including our IRR and lease price, we found these under the constraint of setting our net present value to 0, achieving an IRR for our solar-only systems at the current market standard of 7.5%, basically ensuring that our proposal is economically competitive. Our battery-only system actually achieved a positive return to investors and an IRR above current market rates of 10.25%. Overall, our recommended system provides UCF with savings through sustainable energy implementation. Hopefully it can inspire many others who see it to do the same, and it will make UCF a leader in innovative solutions for a sustainable future. And with that, thank you so much for this amazing opportunity.
Awesome. Thank you for University of Colorado, Boulder. Now, as they turn off their cameras and our next team turns theirs on, and we bring up the next presentation, I'm pleased to introduce our final presenting school as Embry Riddle Aeronautical University. They scored top marks in all 5 judging areas from their judging panel and were chosen as the winner of the University of Nebraska-Lincoln Division for their focus on the 3 C's: clean, cost, and community, which I'm sure we're going to find out what that means in just a few minutes. So I'm waiting to see all of the students join, and I see the presentation is up. With that, I'll turn it over to University of our Embry Riddle Aeronautical University. Go ahead.
Hello, everyone, and thank you for taking the time to watch our presentation. We are the Embry Riddle Aeronautical University Solar Studs, and we are presenting our pitch presentation for the Solar District Cup 2021. There we go. So here is our team. Today presenting, we have Jennifer, Elijah, and Eric. So we were given the University of Nebraska-Lincoln, or UNL, as our district. It's a large public university located in Nebraska. If you take a look at the Global Horizontal Solar Irradiance Map, or the GAHI map, it's a measure of how much solar UNL can use, and it's moderately low compared to the rest of the US. Another thing to consider is that UNL it wants sustainability on their campus, and the way that they're doing that is through the Chancellor's Environmental Sustainability and Resilience Commission. So what was our solar stud system design approach? We focused on the 3 C's: clean, cost, and core and unity. Core and unity is a term our team created to encompass UNL's Husker spirit and strive for sustainability. So for clean, we're going to incorporate solar power onto the University of Nebraska-Lincoln campus. For cost, we're going to design a cost-efficient system that is cheaper than the current non-renewable energy utility. And for core and unity, we're going to engage the UNL community in campus-wide sustainability efforts. I'm going to pass it off to Elijah to talk more about our system.
Thank you, Jen. I think a good place to start is that Nebraska is actually the only state in which all electricity providers are publicly owned utilities. This definitely shows itself in UNL's utility rate schedule, as they are being charged only 2.5 cents per kilowatt hour for their energy, which is extremely cheap as far as Nebraska and the rest of the United States goes. So, if energy is this cheap, how do we design a photovoltaic system that will be cost efficient? I'll tell you how. We're going to attack the commercial demand charge from the utility rate schedule. This demand charge is being charged for UNL as more than $21 per kilowatt of billing demand per building per month. If we can cut that billing demand, we can create a profitable project for photovoltaic panels and battery storage systems. So, in summary, our design hits the 3 C's. For clean, we offset 5% of UNL's energy needs with our 880 kilowatt solar panel system. And for cost efficiency, we have a total project NPV of about $180,000 and an IRR of about 7.52%. For core and unity, we comply with that Chancellor's Commission for Environment, Sustainability, and Resilience. We incorporate the Warren Buffett Solar Center and agrivoltaic research stations. And all in all, we just put the corn back in corn huskers. So let's take a tour of our proposed systems. First, we're going to take a look at East Campus with 5 independent systems. First, we have the Northwest Carport Lot, providing power and energy to 11 separate buildings on the East Campus, along with their separate battery systems. This carport is also associated with EV charging. Next, we have the Animal Science Complex, a 205 kilowatt system split between an EV-enabled carport lot as well as a rooftop mounted solar panels. Finally, we have 3 separate rooftop systems, one being Law College with 40 kilowatts and its own battery, another being Barkley Memorial Center with 22 kilowatts, and finally, the College of Dentistry with about 41 kilowatts of solar panels on its roof. Next, we're going to look at City Campus, and we'll touch on that corn later, but first we're going to look at Andrews Hall, a 29 kilowatt system with its self-associated battery system. Next, we have solar pole mounted signage in and around UNL City Campus. These are at eye level and layered with solar skin in order to showcase UNL's diversity and ability to showcase their dedication to sustainability with university signage and maps all around campus. Finally, we have the rooftop system known as the corn. This will also be layered with solar skin to provide an image of UNL's proposed sustainability initiatives and dedication to sustainability around campus. Next, we're going to be looking at the agricultural field. First, we have 3 separate agrivoltaic research stations. With about 500 panels, these are placed in various locations as to not interfere with existing crops, but provide research opportunities for students and faculty. Finally, we have the dubbed Warren Buffett Solar Center. Named for one of the UNL's most prestigious graduates, Warren Buffett, this provides a community center location ideal for farmers markets, movie nights under the stars, and all types of community engagement events. Jen, why don't you go ahead and keep going about agrivoltaics?
Sure. So agrivoltaics is a symbiotic relationship between agriculture and PV systems. Our team was inspired by this up-and-coming technology, and we designed 3 research stations with varying spacing to provide a varying amount of sunlight. The first station is 2 feet of spacing, and that's for vineyards, beans, and oats. The second station has 4.17 feet of spacing, and that's for wheat and vegetables. And our third research station is for corn with 6 feet of spacing. All right, Elijah, you talk about resiliency.
Yeah, of course. So ideally, resilience is the idea that you are able to withstand an outage and sustain a building's critical load.
For our challenge, that critical load was the animal science complex, with 30% of its load profile needing to be met at any given time. Ideally, this will be an insurance policy, ensuring the system's saving of $2 million worth of crucial inventory for UNL. Additionally, our system is completely reliable with 95% confidence that it will sustain our assumed 3-hour outage.
For our equipment selection, we decided to choose a high efficiency solar panel and inverter, as well as 2 different residential sized batteries to help with peak shaving. For our resiliency battery, we combined 4 Tesla Megapacks for a combined 200 kilowatt, 800 kilowatt hour resiliency system with a depth of discharge of 100% during an outage. For our expected operation of each battery system, we will be using a peak shaving algorithm in which each battery will be serving, helping with PV to peak shave those loads. For our distribution system impact analysis, we have 2 main metrics of interest, over/under voltage, as well as equipment overloading. When these metrics are violated, it causes things like damage to insulation and decreased equipment lifespan. And for our methodology, first we evaluated the base case, implemented our proposed system using NSRDB irradiance and temperature data, conducted a sensitivity analysis of 4 different situations where high stress would be placed on the system, and identified an equipment upgrade necessary for the agrivoltaic transformer.
Our financial inputs included the PV capital cost of about $1,600 per kilowatt, deferring commercial and residential battery costs due to the size of the batteries and the costs associated with them, and the federal 26% tax incentive used to justify the cost of our project. Our financial outputs include a 12-cent per kilowatt hour PPA price, an IRR of 7.52%, and a payback period of 11 years associated with the project NPV of $187,000. Our resiliency challenge NPV, while about negative $300,000, actually sustains about $2 million worth of avoided outage costs, bringing the resilience benefit up to about $1.7 million.
The development plan highlights the important steps to construct the system within an 8-month timeline. First, you need to understand the zoning ordinances, then acquire the necessary permits and documentation. We ensured that our proposal was in compliance with UNL's master plan titled Plan Big, and we identified potential risks that could delay our construction. Finally, the main focus of the solar studs is to design a system that promotes sustainability and engages the UNL community. Our system, such as the Warren Buffett Solar Center, or the Corn, will bring the campus together in a new and greener way.
Thank you so much.
Thank you.
That is the end of your presentation. We really appreciate all the teams who took the time to tell us about their story today. So I'm going to turn things over now to Kelly Speaks-Bachman again for some remarks and instructions on voting for the Project Pitch Champion. Kelly?
Oh my gosh, how much fun. These were great pitches, everybody. I feel like I'm on an episode of Shark Tank. Great ideas. Love the corn love. There's just all kinds of really cool stuff going around. I'm excited to see who actually wins, but in my book, you're all winners. This has been just a really fun time this afternoon. We're going to begin the voting process now. We're activating the Zoom poll feature, and you'll have a few minutes to select the team that you believe will be our project pitch winner. The poll should now be visible on your screens. Okay. So
I can confirm it is visible and we see votes coming through. I don't think you can see it, Kelly, but it is out there.
I was just wondering that. Thank you. So as we're counting votes, I did want to actually talk a little bit about EERE and our goal of working to accelerate the clean energy revolution. Really, we're moving technologies really from lab to market. And this is just a really exciting time to be a part of such activity. We're focusing on how we can bring an impact to a 100% clean grid by 2035, and how we're going to use these technologies to decarbonize transportation, buildings, industry, and agriculture. I'm proud that we've already hit the ground running since the Biden administration took office in January. We've invested just since January 20th, more than $260 million in renewable energy, both in research and development and in deployments. We're backing up this target with nearly $128 million in investments to lower cost, improve performance, and speed the deployment of solar energy technologies. And we know we can't do it alone. We're writing the next chapter in a clean energy revolution. And that's going to require entrepreneurs, scientists, citizens, innovators, and students like you coming into the workforce. So let's see, everybody did just such a great job. I just wanted to let you know also that they asked me to talk a little bit about the next round. So as this round of the Solar District Cup is coming to an end, you should know that another one will begin, and the next batch of students will have a chance to advance the vision of decarbonizing our economy. Registration opens already tomorrow for the third class, which will launch in the fall and complete in 2022. Your support will make sure that the brightest and the most talented students across the United States can participate. So please share this program with your colleagues and your peers at other universities. And so we'll just be waiting to hear who the winner is. I think the votes are still coming in. I can't see though, Joe, can you?
Yeah, so I can see that just about 95% of those on the call have voted, and
awesome.
The results, I know what they are. They should be coming through to you now. It should be in the Zoom chat for you to be able to announce who that result is. Let's see if we can find that.
Okay. We have a winner. You guys ready?
I have our trophy.
Okay, so all three of today's pitches were just outstanding, and I am so proud of you all. We should remember that all the teams have made an invaluable contribution. There's no doubt that our clean energy future is in great hands, but for right now, I am pleased to announce that our champion team is, drum roll please, University of Colorado Boulder. Would the team members from the University of Colorado like to say a few words?
Yeah, I can speak for our team real quick. I first of all just want to thank everyone on our team. We had about a 10-person team. Only 5 of us got to present today, but it would not have been possible without the work of everybody. We want to thank our faculty advisor, Dr. Walker, for introducing us to this competition and helping us along the whole way. We want to thank the NREL advisors. I know that I attended every webinar and had a great time with them, and I feel like everyone on our team has learned so much from this experience. And then the family and friends of everyone on our team who helped us as we slogged through 20-hour work weeks in an online semester to get all of this done. But we just want to thank everybody. It's a great honor.
Awesome.
Congratulations, Devin. Just congratulations again.
Thank you.
This is so exciting. So also, I want to say thanks to everyone who competed in the Solar District Cup class of 2021. I am so looking forward to the next round of competition, class of 22, that's going to span the 2021 and 2022 academic year. So whether you're a student, a faculty member, or an industry professional, we invite you to get involved in the 2022 program. Go to herox.com/Solar District Cup for updates. You can see that right there. Okay, so that's it. We are through. And we are so grateful for your time and your support and all your ingenuity. This has been just an amazing experience. Thanks, everyone.